Hello everybody, welcome to the channel again and out of the rundown matrices lane. Today we're looking at how to use the recurrence rule to calculate state matrices. So here in this question we're given a transition matrix, not told anything about it, and also a state matrix, which is the first matrix in the sequence. And we want to use the recurrence rule, Sn plus 1 equals t times Sn, to determine S1 and S3. Then down the track it gives us a couple of other options. So let's go ahead and do A first. Okay, so A, let's use that rule to find our answers. Now I'm just going to dive straight into it with really no working out for this one. We'll just go straight into the K's. You can see I've got T and S all already put in there. And all I'm going to do to find S1 is times the transition matrix by S0. So go. Okay, so what we've done there is we've gone S0 plus 1 is equal to T times S0. Okay, and that will give us S1, which is equal to, as we can see there, 80 and 120. Okay. The next one, part 2, asks for S3. Now, that means if we want S3, you can see that to get S1, we needed S0, the previous state. So to get S3, we will need S2, right, which means we've got to continue through this process. Now that's not too hard on the CAS, we've already got this here. We're going to go and use transition times our answer, so that's S1. I'm going to press answer and hit that. That's S2. Now it will repeat that same equation for me if I just hit X here again. So it's going to use T times the answer, which was that. And there we have S3. So S3 is equal to 68.8 and 131.2. Next up, use the recurrence rule, Sn plus 1 equals T times Sn plus R, where R is 10 and 5 as a column matrix, to determine S1 and S2. Okay, so B, let's make this black so we can differentiate a bit. Now I'm just going to pop B in here, pop my column matrix in, and it's 10 and 5. Call that R for the sake of consistency. Alright, so now I am going to go and do T. So for this one, for part 1, let's write this out a little more clearly. For part 1, we're going to do S0 plus 1 equals, going to plug in our transition matrix, times S0, and then we're going to add R to it at the end. Okay, and that is going to give us the value of S1. Okay, so we have T times S plus R. Okay, T times S plus R, and we get that. So S1 is equal to 90 and 125. Okay. Now you can see that the difference between S1 up here and S1 here is just this. The values here, so 10 greater than 80 is 90, and that should be, what have I done here? That should be 120, I think. I missed that 0. And 120 plus 5 is 125. Okay. That won't continue for this next phase though. Oh, that's S3 anyway, but because we apply the transition matrix to this first, it's going to change the ratios that it goes up by compared to when we used S2, S1 to find S2 and so forth. So that's only going to be any good there. Number 2, part 2, we're going to do S1 plus 1 is going to give us S2, and that's equal to T times S1 plus R again. So on the CAS, this is going to be easiest to do by T times our answer and then plus R. Okay. And we get $89 and $141. Okay, so that's S2's value. And over here for part C, we have the same situation, except this time we are subtracting a value there. Let's make it green. Hopefully no one's colorblind. So part 1, so we're going to find S1 and S2 again. So for S1, same deal, we go S0 plus 1 equals T times, that's the matrix of T times S0, and then we're going to subtract B instead of making an addition this time. Dodgy B. And let's pop in the value of that matrix, column matrix, and we needed -20 and 20. And we're going to name that B. Alrighty, so part 1, we do T times S again, subtract B, and we get 100 and 100. So that's S1's value. Now I've got a prediction that S2 is going to be the same, because we can see that S0 is up here, and that started as 100 times 100 and 100. So whatever is happening here is simply taking away the extra portion that this transition matrix is adding to anything. Okay. So at the end of the day, if we did 0.6 times 100, so 60, and then 0.2 times 100, so they equal 80 all up. And this matrix then subtracts a -20 from that top number, from our 80. So subtracting a -20 is the same as adding 20, so that takes it back to 100. And a similar thing is going to happen down here, except when we do these two, we're going to end up with 120, and it's going to subtract 20 from that. Okay, so for the sake of process, we'll go through with it. I'll just scroll down a touch. S1 plus 1 is equal to the transition matrix that we've got times S1 and subtract B. For the sake of being thorough, we will do that and go T times our answer this time, just for good practice, minus B, and give us an answer, and we get 100. Surprise, surprise. So S2 is equal to that right there. Okay, hopefully that helps you out in this path along matrices, and we'll go into a little more depth later in this topic. Okay, if you've got any questions, put them in the comments, and if you like the video, give it a thumbs up and subscribe. Cheers gang, hope everything is good.